Okay, so for this sample problem, this is number 2 on your worksheet. The problem states that we have originally unpolarized light with an intensity of 46 watts per meter squared that strikes a polarizing sheet at an angle of 25 degrees to the vertical, and then a second polarizing sheet with an angle, the polarizing angle of 40 degrees to the vertical. And it asks, what is the intensity of the light after the light passes through the second sheet? Okay, so we have originally unpolarized light, okay, in all directions. It's coming and it strikes this first polarizing sheet, and that polarizing sheet orients the light in the direction of the polarization. So the light comes out at 25 degrees to the vertical, but it also decreases the intensity of the light by half. This is the 1/2 rule for originally unpolarized light only. So I'm going to call this, here's I naught, and here is I1. Okay, so I1 is going to be equal to I naught over 2, because we're starting with originally unpolarized light. So I1 is equal to 46 watts per meter squared over 2, which means that it is 23 watts per meter squared is the intensity of I1. Now remember, it's also oriented at 25 degrees to the vertical. So this polarized light, now we're saying this is polarized, and it's polarized at a direction of 25 degrees to the vertical. Right here, right? There it is, 25 degrees to the vertical. And it comes up and it strikes a second polarizing sheet, which has a angle of 40 degrees to the vertical. The cosine squared rule tells us that the intensity of the light after the second sheet, I2, is going to be equal to the I1, right? The intensity of the polarized light times the cosine squared of theta. Now remember, that angle is the angle between the polarized light and the polarizing direction of our sheet. So it's this angle in here that we're looking for. Well, if this is 25 degrees, right, from the vertical, and then full on to here is 40 degrees, what's in between that? It's 25 minus 40, it's 15 degrees. So we can plug that in. We say that I2 is equal to I1, which is 23 watts per meter squared, times the cosine squared of 15 degrees. All right, when we plug those numbers in, we get a final intensity of 21.46 watts per meter squared for our final intensity. Good to go? Okay, let me know if you have any questions. I hope you have a great day.